Good morning, everyone, and welcome to the third AATF Technology Thursday webinar. Today, we have an innovative presentation from Adroit on all things cloud from the industrial market, Adroit IoT, OPC, Edge Gateway, enabling the fourth IR with local technology. Today, our presenter is Adroit's MD, Dave Wibberley. After leaving university with a degree in mechanical engineering, Dave joined GEC Large Machines as a mechanical design engineer. In parallel with his work there, he studied part-time and earned a graduate diploma in industrial engineering. After completing his time at GEC, he started a systems integration business, NC Automation Engineering, in which he earned his stripes in the practical aspects of project engineering, specializing in SCADA and HMI aspects of the business. After 10 years, he sold out and joined Adroit Technologies as the International Business Development Director for fledgling Adroit SCADA HMI software. After a year, he was appointed Managing Director and has remained in that position for over 20 years. Please feel free to use the question and answer facility at the bottom of your screen throughout the presentation, and there will be time for those to be answered after the presentation. Without further delay, let's begin the presentation. Thank you, Dave.
Good morning to you, and welcome to the AAF webinar series. Today, I'm doing a presentation around all things cloud for the industrial market, to give you some idea of what that landscape looks like, and in conjunction with that, to explain how we as a company can assist you, and no matter what SCADA that you have in
Please bear with us. We're just reconnecting and fixing the technology on the side.
Place, or whatever your strategy may be, that we can assist you with getting along that road without too much pain. Right, so what is the fourth industrial revolution all about? What does it mean? What does the cloud landscape look like for us in the industrial automation world? What are the components that make that up? How do I choose a platform, or do I go with the vendor's product delivery? And how can we at Adroit Technologies use our technology to assist you in achieving those goals? And then, of course, at the end, we're going to have a discussion with the panel, and hopefully that will deliver even more value. So what does this fourth industrial revolution really mean? We often hear it in our own context in terms of the industrial world, but it's a huge concept that is being mooted around the world, hopefully trying to change the world a little bit into a better place. And if you look at this map, if you want to, mind map of the fourth industrial revolution as defined by the World Economic Forum, there is it's a huge concept in terms of delivery. So how to deal with disruption to jobs, security and conflict, agile technology, governance, ethics, fusing technologies, inequality. So how can this concept of the fourth industrial revolution support betterment for the world in all of those things? And on the outside are functions that all have their input to these various 8 core concepts in terms of improvement. And if you look at our world, we are dealing with first of all, a minority of those 8 concepts, which is fusing technologies, I guess, and innovation and productivity. And then on the outside, the ones that we really are focusing on are these 7, which are virtual and augmented reality. You've heard a lot about that. Artificial intelligence and robots. 5G, I think, will make a big difference. Again, it's just part of the communications. The Internet of Things, cybersecurity will impact us, digital communications, and advanced manufacturing. So you can see we are dealing with a small subset, and it's a very complex environment. And really, we can only do what we can do, and we are going to focus on the industrial world. So, but it's all about, at the end of the day, there's nothing more about this than extracting more value and efficiencies from the data that we produce in our control systems, augmented by things such as IoT and other inputs. But at the end of the day, it's all about extracting more value. And my go-to person on this stuff is a guy called Russell Aatf, who defined the hierarchy data value model, if you want to, which starts at the bottom. I'm sure a lot of you have seen this, from data to information to knowledge to understanding to wisdom. And he attempted to actually put a definition to each of these layers so that you can define exactly where you are in that hierarchy. And he also mooted that information is 10 times the value of data, knowledge is 10 times the value of the information, understanding is 10 times the value of knowledge, and wisdom is 10 times the value of understanding. So if we look at that, let's just look at the hierarchy, and these are his definitions of those layers. And it's important to get them in our heads right now in terms of trying to understand what we're doing and where we're going. So data are symbols that represent objects and events and their properties, and they are products of observation. So to us, that's temperature, pressure, stuff that we can measure. Information provides, if you have an information system or you at that layer, you can supply answers to questions that begin with who, what, when, and how many. That's databasing, that's historians. How many times did that motor turn on between that time and that time? Knowledge consists of know-how, knowing what to do and what not to do. In other words, don't turn that motor on if this condition is in the plant. That's when you have some knowledge. Understanding is answers to questions that begin with why. Why didn't the batch work? It started off with exactly the same ingredients. Why didn't the batch work? And wisdom is the ability to perceive, to evaluate the long-term consequence of behavior. In other words, if I tweak that, I know because of all the stuff that's gone around me, what will happen and what the consequences of those decisions are. And if you consider what he said to you, and each value being 10 times, wisdom is 10,000 times the value of the underlying data. That's enormous value lying in there. So before we get carried away, 40 years of automation, and we are still really at the data and information stage. And the fourth industrial revolution is all about how we move up the value chain using the data and the technology that are supporting that are cloud services and other smart technologies which are making that more possible. IoT, supplementing data, more data. The more data we've got, the better models we have, the better outcomes, the better we understand, the higher up we can go. So technologies such as AI, which encompass machine learning, deep learning, I'm not going to go into those today, but certainly those are the promised technologies that will deliver and move us up the hierarchy. Right now, we are sitting on the information and the data layer in most plants. Historians, databases supporting plant data, some with structured, unstructured, some with structured, contextual-based data. We certainly are getting better, but we're still sitting in the information age. Just to supplement this, the IoT revolution is being driven by the perfect storm. And that's a perfect storm of these three laws: Moore's law, Metcalfe's law, and Kumi's law. And without going into detail, Moore's law is about how computational density has gone up over the years. Metcalfe's law is the value of any network being a square of the number of connected devices or nodes. And if you think about it, IoT, 4G, the telecoms networks, our own standard networks, everybody is connected everywhere. So the value of this network that we have, all encompassing, is enormous. And that's Metcalfe's law. And Kumi's law is the cost per kilowatt hour of processing has come down enormously. So you've got very powerful processors using very little power in a network that allows you to transfer the data and use and consume the data anywhere you want in the world. And those coming together are really allowing us to get things such as smart sensors, low-powered sensors, IoT sensors that you can put in cheaply to support the data that supports your 4IR strategy. Again, I'm not going to spend too much time. You know about the fourth industrial revolution, but one was steam, assembly lines, computing, internet, nuclear, and the fourth one is all about digitization and the coming together of cyber and physical systems. Right, let's have a look at the landscape and how it supports us in the automation world. At the bottom, you've got sensors, which can then deliver data, if you want to, into PLCs and control systems via RTUs, alternatively via a network directly, and then specialist networks such as IoT networks like Sigfox, which will allow you to put the data either into a SCADA system, into a plant-based system, or directly into the cloud. And then on the right-hand side of the cloud, you're seeing big players like Azure, Microsoft, Amazon, Google, Huawei, IBM, all racing to try and offer customers the best technologies to support the extraction of that value in the data. And those are the big guys. To give you some idea, I think Microsoft, I remember, spent $5 billion on building this smart Azure cloud stuff, which is enormous amounts of money. So how does the cloud work? Basically, every one of them have got something like an IoT or event hub, and you can transfer data using protocols such as OPC UA, MQTT, or directly into the IoT or event hub. And following that, which is, and now, by the way, the IoT event hub is just a storage, a temporary storage of real-time of the data. Then you've got to apply services on the right-hand side of that to extract and move the data into something that is useful for you to build an application. So basically, if you look, if you look at the Microsoft Azure platform, there's a category, and each of those categories, there are a lot of services that you have to implement in order to extract the value in some sort of application. So that is a complex animal all by themselves. And if you thought our world was complex, the cloud world is frightening. To give you some idea, if you just take the IoT or the Internet of Things category in Microsoft, there are over 20 services that you can implement on top of that to achieve the Internet of Things, some value from the Internet of Things data. That's just IoT. If you look at machine learning, there are 38 services potentially that you can use. Analytics, 16 services. So again, it's really critical that you understand what type of problem you're trying to solve in order to assist you in choosing what services you are going to implement on top of the data that you are putting into the cloud. So let's just step back. What is edge computing? Edge computing is defined as a distributed computing paradigm that brings computation and data storage closer to the location where it's needed. In our terms, process the data as close to the data as possible and only use the data that you want in the higher level systems. Don't make the same mistakes that people have made in historians, where the philosophy has been log everything and we worry about it later. That has just cost enormous amounts of resources, and you have to scrub that data somewhere in order to make sure that's fine. You want to scrub the data as close to the data as possible and put the data up in the cloud. So you don't want to put every second, put a level in a hopper that is moving very slowly. You want to maybe take once every half an hour, take the snapshot and put it up. Same time, if something's changing a lot, you may want to just take the average. You don't want to put, if a speed is varying very quickly and a lot, maybe the average speed is important. So average it at the SCADA level and put the average up into the cloud. Right, so how can we help you? We are about to launch our OPC Edge Gateway, and what that does, it allows you to implement MQTT, OPC UA, or a direct connection from your SCADA system, which again is talking to plant systems. And we are, on the right-hand side, you can see that on southbound, we offer you all the connectivity you want. Northbound, we can put it directly into the cloud using various technologies, or share information using OPC UA, etc. And in between, you take advantage of our agent-based technology, which allow you to extract the value, and it's acting as an edge computing device. So you can take lots and lots of data, take the average over half an hour, and take that one value and put it into the cloud. So that's what the Edge and OPC gateway that we are delivering can do it. So just by way of an example, we are going to show a demonstration where we have a mining crusher simulator, which has implemented our machine-to-machine protocol for remote monitoring. It's sending out data into the Adroit, into a cloud. We've got an Adroit sitting in the cloud, and then we are using our Edge Gateway capability, where we are taking those values that are coming in from the field and squirting it directly into the Azure IoT Hub. We've implemented a SQL Server service, if you want to, which moves that data from the IoT Hub into SQL Server. And then we're using a service called the Real-Time Insights, which are one of those services. And it allows us to really do a graph of the time-based data sitting in SQL Server. So again, we're now going to compare what's coming from the cloud and what's sitting in the hub, and you'll see that is near to real time, which means these technologies, if you're clever, can deliver near real-time value back to your environment. In fact, it is emulating the data that's happening in the field. You can see on the SCADA system, the hopper is empty, the conveyor is stopped because there's no truck, and the crusher stopped. So basically what's going to happen, if you look here, is I'm going to first of all put the truck in place. So by clicking that switch, you'll see that the loading apron and the conveyor start running, although the hopper is empty, and I'm going to start the crusher. And if you look at the screen, you'll see now that they are both green. The crusher is running, we're off taking, and you can see now that the level in the hopper is rising. And then all it's going to do is go between the high level and the low level. And depending on the speed, and the speed you can see here is adjusting. Right now it's around 80 odd kilos. If I now reduce it, I'll reduce the speed of the offtake. You will see that the speed comes down, and of course then the hopper will go up and fill a lot quicker. So that's all it's going to do, and basically what we're doing is we are collecting the data using the M2M protocol, transferring that to the Adroit demo in the cloud, and from there we are now every minute processing that data, taking the same data that we have here and popping it straight into the Azure IoT Hub. And from there, of course, your analysts can take that data and analyze the plant. We've set it up that it only transfers the data from the cloud, our cloud, no, it's the Adroit SCADA sitting in the cloud, to the Azure server once a minute. So again, you've got to be aware that in a normal process, that this is a process that doesn't change very quickly. And let's do that. You'll see that, in fact, we've set up the PLC emulation that the crusher fills at about 100 kilograms a second, and we are now taking off at 84 kilograms a second. So what I'm going to do is slow that down. So I'm going to bring the speed of the conveyor down to about 50 or maybe even 40. You can see on the right-hand side, it is coming down on the graph. And I've reached the high level, or the high level set point, the cutoff, which is about 800. It takes a little while, of course, to empty the conveyor. We try to emulate exactly what it happens. And what I'm going to do now is shut the conveyor off. You can see my speed of the conveyor is at 44, and that's the important one to see in the cloud. So once a minute or at some point in time, the operator slowed the system down. And that's the important stuff that we need to be able to simulate the data in the cloud. So you can see both. It will have gone up. And if you notice on the right-hand side, they are both flatlined. So that's where we're sitting at. And if I pop across to the time series insight and I refresh the data, you will see, let's just go and look at that value, and it's gone up to 1388. How does that compare to here? You can see that it's a little bit behind. Obviously, you didn't get the last feed, but if you just wait a couple of minutes and we refresh that data, that will in fact increase to 1000 to the same value. Likewise, you can see that we reduced the speed here to 44, and if I compare that to what's happening in the cloud, that's exactly what we've got in Adroit. So that's the power of this stuff, and we suggest what you do is please come and talk to us if you have any requirements to use Adroit as your edge gateway for events, for alarms, for data sitting in databases. It's the same mechanism. We will be selling this as a separate product all by itself as an IoT and edge gateway, which gives you access to. Okay, so that was the little demonstration. As you saw there, it's pretty real time, and we're injecting that data every minute and refreshing that insights time series insights chart shows you that this is pretty near to real time. So if your application on the other side is processing that data and maybe intelligently working out the best or optimal milling circuit, then obviously you would get that potentially fed back into a PLC in almost in close to real time as well. So in conclusion, what is the best digital transformation strategy or path to follow? And again, I'm going to just share some, this is not rocket science. It goes with any sort of more complex approach. There is enormous value to be had, but it could be a very complex exercise. So don't do it for fun. It's an expensive, complex, and time-consuming exercise. You should always focus and start in the end goal. Don't do it for fun. Start and solve a problem. What do you want to achieve? And don't worry about the technology too much. Define the problem first. Is it an energy problem? Is it an efficiency problem? Is it a process or a quality problem? Or any other challenge that you may have. Choose your partner who understands your goal, and together choose the technology partner or whether it's vendor specific or a native cloud solution. And they all have their positives. Certainly the more vertical specialized solutions that are coming out from various people may be a better solution, maybe easier to use. If you're going to go and write your own, that can be a very costly exercise, but again, you'll get exactly what you want. And I think that's a key element of certainly a successful project. And again, choose a good edge computing strategy. Adroit is a great product, and our OPC UA or edge gateway will solve and be able to do 95% of any control systems strategy around doing that. And again, good luck. Fortune favors the brave. So just to reiterate, very simple, define your goal, choose the tech best suited to solve the problem, execute a small project, measure your success, redefine your goal, and go forward. So in conclusion, thank you very much. I hope it was informative. Please send any questions you may have to davew@adroit.co.za. And I'd like to thank the guys at AAF for giving us this opportunity, and I look forward to an engagement going forward.
Great. Thank you so much, Dave. That was really, really informative and quite high level stuff, but very exciting to see what is on the landscape from a cloud perspective. So as mentioned, there is an opportunity for questions and answers. And I'll be handing over to Dave and his team. The team is inclusive of Rudy Tufik, the owner of All Pronics. And then from Adroit, we have the following panelists: Dean Gibson, Bradley Campbell, and Hugo Pinar. So thanks again to all of you for joining us, and we will be taking those live questions. Some questions have already come through. So as a reminder, just use the Q&A box at the bottom of your screen, and I'm going to hand over to Rudy and Dave to answer those questions.
Rudy, are you there?
Okay, Dave, yes, I've got some questions for you. The first one is from James. He's asking, how safe is the transfer of data directly to the cloud? Do you use firewalls?
So simple question to that is, obviously OPC UA has got a long way to adding the sort of security layers with certificates being implemented, but the OPC UA to the cloud or Azure is not a simple, straightforward exercise. If you're using OPC UA, there's usually a third party, the same with MQTT. So all these protocols have been built with security in mind. In our OPC Edge Gateway product, we have implemented a direct connection into these IoT end hubs. And in fact, those are all conform to the Microsoft requirements around security. So there is certificates as well as it uses HTTPS. So yeah, you have to go through firewalls from your side. Just remember, you generally are pushing it straight into the cloud. So yeah, it's very secure.
Okay, thank you. And then I've got one from Anonymous saying, looking at your end-to-end demo, you were remotely operating a crusher. How will we implement safety features to allow remote operating of dangerous machines?
Yeah, well, listen, I wouldn't advocate certainly the operating of remote machines remotely without some very robust control at the machine itself. So we were just extracting data from the machine there, but of course it is bidirectional control. So technically you can do it, but again, that's just practical application and safety features implemented at the PLC level in order to protect anybody at the machine. So yeah, that needs some thought specifically if you're doing control.
Okay, I hope that answers you. And then one from Mr. Williams. What is the smallest platform one can use as an edge device?
So again, we are selling our product in the same I/O sizes as our SCADA system. So it goes, you can buy a small one. That's the nice thing about the way we're going to be selling our product, is that you can start small, put a 30 I/O system down and go upwards to unlimited. And I think that's the value of what we're going to bring to the table as this edge gateway. So yeah, it's completely scalable. And I think that's the advantage of what we're going to bring to the table.
Okay, while you're talking about edge, I've got a question from Lance. What is the advantage an edge device has over a local data center, which is also close to the plant operation, also has compute and data store capabilities, offers hard real-time as there is no dependency on known cloud latency issues?
Yeah, I read that question. It's a little bit, it needs more conversation, because is Lance saying that he wants to do his sort of smart AI stuff at the data center? But it doesn't really matter what you're using. If you're using a local data center and you're processing and then putting that in the cloud, it's the same thing. It's acting almost as an edge device. If he's looking at using a local data center to store all his plant data and then do all the AI on top of that, that's also okay. It's just a different strategy. I think the advantage, the possible advantage of going cloud is this enormous investment that people like Microsoft and them are going into making the technologies available to customers. And I say that with great big inverted commas around making it available. You know, this is still the domain of people like the data scientists. I don't think it's ready as yet, or plug and play like we would maybe think it would be. So that, again, it's about trying to understand your problem you're trying to solve You know, even our guys, we implemented one service just to do that real-time analytics or insights, and that was just to have a simple time-based time series look at the data in the cloud. So that needs a conversation. Lance, do me a favor, just drop me a mail or give me a call, and I'm happy to discuss that.
I've got another 4 questions here, but my Q&A box has just gone blank here. I don't know if there's someone else on the panel that can read.
Let me carry on. The first one, there's an anonymous one for, is IoT the future of PLC? No, certainly you're not going to make, you know, if you look at the people advocating 5G and its capability and the lack of latency, and I've seen some incredible control systems done over 5G. I am maybe a bit old school, but certainly I'm not putting any control or safeties up in the cloud to make decisions on switching IO in the field over IoT. Certainly not. No, the PLC is here to stay and will be. It's a bit like arguing the soft PLC on PC-based control systems. That didn't last very long. That's because the cost of a PLC and the value you get in terms of robustness and reliability is uncomparable still. And so that's not going to happen. It's going to complement these higher level knowledge systems. Koketso asked a question. Thanks, Dave. Do you recommend Adroit for building management end-to-end solution incorporating energy? Yes, I do. Adroit's a very horizontal product. We run some very large, we're running the 4, well, we're currently commissioning 4 of the biggest new hospitals in Turkey, all running Adroit, doing all of that stuff, asset management, energy management, security. So yeah, it's a perfect platform for doing that. We have BACnet as a driver, which then falls nicely into that domain. So yeah, you can use Adroit for any of those things, certainly. Then Kenneth McPherson, what is your recommendation for connection, edge computing to the cloud? It doesn't really matter. This stuff, as you've seen, Kenneth, is pretty real time. In fact, it's seconds, if not milliseconds, if you've got a decent connection into the cloud. That time is not an issue. Anonymous have asked, what are the main cost drivers to implement such an edge IoT? It's going back to Russell Aatf. I think if you believe there is some more value in the data that you possibly AI can uncover, then, but again, I think you need to define your problem and trying to understand what you're trying to solve. I think there is value there. Certainly the machine learning and the AI stuff may uncover some interesting models and replace certain humans for those sort of complex decisions. Again, it's quite early on. So as an example, we work with some guys in Belarus on a smart water management system, which they've built on top of Adroit. And they've implemented AI based on trying to optimize an optimal water pumping station. So if you've got three pumps of different sizes, and maybe one's on a variable speed drive, and you're trying to optimize the running of that pump station against cost, as an example, to ensure a certain quality of supply, that sort of stuff you can do. Yeah, that's local. That basically does neural network and advanced mathematics to build a model based on the history, and then that can itself decide what pump to run when to achieve the outcomes. And that we are looking to do using that technology locally. So again, depending on the problem is what you would choose to solve. Mervyn Frampton has asked, when I see photos of the cloud computer installations worldwide, they appear to be relatively insecure. I know that data is shared between cloud computer systems, but this lack of security concerns me. If a rogue country wishes to bring the cloud down, Mervyn. Yeah, Mervyn, I think that's why Microsoft spent $5 billion trying to get this done. You know, cybersecurity is is much a concern of anybody's. I suspect they won't, that's a complex problem being solved at national and level, and security is obviously a big issue. It's a difficult question. Raspberry Pis yet? Yeah, I mean, that's just, as long as they support a capability of pushing data into the cloud or up into an Adroit system or using MQTT, a lot of those smaller devices are available. And what's exciting about this world is the collection of data using such devices is making this world exciting from a point of view of adding more data into the claim. And we're using Sigfox extensively, whether that's tracking pressures in remote pipelines where there's no power. You can just drop an ADR pressure, one of our pressure devices down, and get the data every 15 minutes if you wanted to, if that was important, and supplement your model in terms of, for example, a pumping or transport model. So that's relatively easy. And I think we're in for a very exciting 10 years. I really, really do. But I do think the next 5 years will only bring us up one level because it's a complex world. And as we get up there and make it more available, I think the results are going to be very interesting. Our concerns are trying to, for example, understand the multidimensional, even the time-based model, where we're trying to understand alarms, events, process variables, external variables like pressure, temperature. Does that affect your process? You can throw all that into the model now, and the outcomes will be very interesting. Well, I think that's about it. I hope I answered the questions. If not, please send me your questions directly, or alternatively via the AAF, and I'll certainly attempt to answer them. And if you've got any projects or you want some assistance, please get hold of me. We really are looking for some customers who want to go down this journey with us, and we're very happy to.
Great, thanks so much, Dave, and thank you to you and your team for a very informative session, as mentioned. And thanks to the audience for your questions. It's always great to receive those and have an engaging session. So thanks again to everybody for attending our third AATF Technology Thursday session. We've got a lot more on the calendar. For all of you who are attending, there is a poll at the bottom of your screen for you to answer. So please give us your feedback, and we want to deliver content that is your preference, and we can do that by getting your feedback. Again, thank you, Dave, and your team from Adroit, as well as Rudy from Allpronics. I think very informative and knowledgeable, and we look forward to seeing what happens in May at the event in 2021. We'd also like to remind everybody about our next AATF Technology Thursday session, which will be presented by Vega. So save the date and make sure you get registered for that session next week. Thanks again to everyone, and have a wonderful Automation and Technology Thursday. See you next week.